everyone, welcome to Physics and Engineering Tutor channel. Kindly subscribe, like and share. Today we'll discuss about electric field. So in this question they are given us 2 point charges of 4 into 10 to the power of minus 19 coulomb and 36 into 10 to the power of minus 19 coulomb are separated by a distance of 2 meter. Okay, two charges, let it be A and B. Okay, so having a value of 4 into 10 to the power of minus 19 coulomb and 36 into 10 to the power of minus 19 coulomb, and both are separated by a distance of 2 meters. Okay, separation is 2 meters. Okay, now find the point on the line joining them at which the electric field intensity is 0. Okay, whether electric field intensity can be 0 between them? Yes. Why it is yes? Because both the charges are like charges. Okay, so there will be a repulsive force between these two charges, so you can have a 0 electric field between these two charges. Okay, now we randomly assume the electric field at a point where it is 0. Let the point be O. Okay, this will assume that at this point O electric field is, but we don't know at what distance it is from A as well as from B. So we are assuming to be at x distance now. As of now we are assuming to be x distance, and from here to here it is x. The total from A to B it is 2, right? From O to A it is x. Remaining will be 2 minus x. Okay. Okay, now we can find out the electric field. So we know the formula of electric field E is equal to KQ divided by R square. Okay, so both have what? Repulsive force. Okay, between two charges you have a repulsive force. So when you keep a test charge at this point O, the electric field will be along the direction of the repulsive force. So the test charge will be repelled by this A. So because both are positive. Okay, so it will be EOA and EOB will be in this direction. Okay, so the magnitude of EOA and EOB will be same. So just equate EOA is equal to EOB. Okay, so use this formula, we substitute the values. Okay, K into, okay, so QA value is 4 into 10 to the power of minus 19, and the distance between O and A will be equal to x square. So which is equal to EOB. So EOB is again K into your QB value is 36 into 10 to the power of minus 19 divided by OB distance is 2 minus x the whole square. Okay, so where EOA is nothing but K into QA divided by the OA distance. Okay. Similarly, EOB is equal to, EOB also is equal to K into QB divided by 2 minus x the whole square. Okay. Okay. So just we are substituting this value here. K into, for QB you have the value as 36 into 10 to the power of minus 19. Just we are substituting it. Okay, now we can cancel the common. You can cancel out the common terms. So K 10 power minus 19, 10 power minus 20. The remaining will be 4 by x square is equal to 36 by 2 minus x the whole square. Okay. Okay, now take the square root on both sides. Okay, so take the square root, then we'll get the answer as 1 by x square is equal to 9 divided by 2 minus x the whole square. Okay, so this we can cancel out. It's 4 and 36. Okay, so 9. So we'll get 1 by x square is equal to 9 divided by 2 minus x the whole square. So now take the square root on both sides. Square root both sides. Then you'll get 1 by x is equal to 3 by 2 minus x. Okay, just cross multiply this. Simplify this, you'll get 2 minus x. This is equal to 3x. Okay, then you'll get 2 is equal to 4x. So therefore, x is equal to 1 by 2 meters or 0.5 meters. Okay, so what we conclude is at a distance of 0.5 meters from A, the electric field point will be 0. Similarly, a distance of 2 minus 0.5, it is 1.5 meter from B, the electric field intensity will be 0. So at a distance of 0.5 meter from A to this point O, the distance is 0.5 meter, then the field will be 0. Okay. Okay, next is point charges are placed at the vertices of a right angled triangle as shown in the figure. Then the magnitude of ECA will be. Okay. Okay. So due to this point charges are given, place vertices of a right angle triangle as shown in the figure, the magnitude of ECA will be. Okay. Okay. So what is the value of ECA? So we know the formula, electric field is equal to K into Q divided by R square. Okay, they asked what will be the magnitude of ECA. So the magnitude of ECA will be is equal to K into QA divided by the distance, right, CA the whole square. Okay, so which is equal to 9 into 10 to the power of 9 into 4 into 10 to the power of minus 6 divided by the distance. Distance is 2 into 10 to the power of minus 2 the whole square. Okay, so which is equal to, we get the answer is 9 into 10 to the power of 7 Newton per Coulomb. Okay, now we can find out what is ECB. So ECB is equal to K into QB divided by CB the whole square. Okay, so 9 into 10 to the power of 9. Okay, into the value of QB is 2 into 10 to the power of minus 6 divided by distance is 10 power minus 2 the whole square. Okay, so we'll get the answer as 18 into 10 to the power of 7 Newton per Coulomb. Okay, now you compare both ECA and ECB because the relationship they are given, the choice is between ECA and ECB. Okay, so you have to find, so that we are finding out ECB also. Okay, even though the question is only ECA, but the relationship is related to ECA is related to ECB. So, you are finding out ECB. Okay, now when you compare ECA and ECB, ECA is half of ECB. Okay, so after comparing this answer of ECA, compare ECA and ECB magnitude values. From this we conclude that ECA is equal to half of ECB. Okay, ECA value is 9. Okay, and ECB value is 18. So when you divide 18 by 2, we'll get the 9. Okay, half the value. Okay. So the option is D. Okay, we'll come to next one is equal charges are placed at the corners of the square of side A. Now we have to find out the magnitude of resultant vector at P due to charges C and A. Okay. So at B, so at this point, due to charges A and C. What is the resultant vector? So we check all the charges are like charges. So at point B and at point A, both the charges are same. So what does the A does? A will repel this B. Okay, so A will repel this B. Okay, so electric field also will be along in this direction because both are like charges. So B will be repelled by this A. Okay, so the force, according to the force, the electric field also will be in the same direction. So ECB. Okay, be in this direction. Then due to C, again both are in like charges. Okay, so the B gets the effect of B due to the C will be, again it will be repelled in this direction. It is your E B C, sorry, it is EBA and this is EBC. Okay, so B is repelled by A along in this direction and B is repelled by C along in this direction. Okay, now what is the angle formed? It will be 90-degree formed. Okay, now we have to find the resultant magnitude of the result vector. So resultant lies along in this direction. Okay, so let it be E dash. Okay, are you able to get? So in the at the corner B point, right? So we have a positive charge, and what is the effect due to this positive charge? And the charges placed at C and as well as charges placed at A. What is the effect of this A charge on B and what is the effect of C charge on B? Okay, so both are repulsive. So it repels B, charge at B gets repelled. Similarly, charge at B gets repelled due to A in this direction. The resultant will be along in this direction. So it is your resultant vector. So you have to do what? Vector addition, parallelogram law of vector addition. Law of vector additions. What is the resultant vector magnitude? So R is equal to A square plus B square plus 2AB cos theta is the formula, right? R is equal to root of A square plus B square plus 2AB cos theta. Okay, here theta is equal to 90 degree. Okay, theta is equal to 90 degree. Okay, now we can substitute. So EBA the whole square plus EBC the whole square plus 2 into EBA EBC into cos 90 is cos 90 degree is equal to 0. So this terms becomes 0. So you'll get only these two terms. So root of EBA E square B plus E square BC. Okay. So at this point B, at B, EBA both will be equal magnitude. EBA will be equal to EBC. The like charges and equal amount they will be repelled. Okay, so the electric field also will be equal. EBA is equal to EBC. Okay, so now substitute. Let this be 1. Now use this 2 in 1. Okay, by using 2 in 1. Okay, then we'll get resultant vector is E dash here. Okay, then we'll get E dash is equal to EB square plus EB square. So which will be equal to root 2 EBC. Okay, so the resultant answer is root 2 into EBC is the resultant vector magnitude due to charges C and A. Due to charges C and A. Okay. Now they asked what will be the direction of the resultant electric field. Okay, so direct resultant field due to C and due to A we have drawn. Now due to D, the diagonal field. If you see diagonally, both are in positive charges only, right? So they get repelled. So again the Q gets repelled in this direction due to D. Okay, same direction. E, D, B. So E dash and EDB will be in the same direction. Due diagonally, both are positive. So B gets repelled by this D. Okay, along diagonal gets repelled. So now the net total, this will be the direction. So the net charge, okay, total at B, total electric field resultant at B will be equal to E dash plus EDB. Okay. Direction will be along DB direction. Direction resultant electric field at the corner there due to charges is along what? Answer is along DB direction. So total electric field vector is along EDB direction. The summation of E dash plus EDB. Okay. So next is the electric field intensity that is required to support a particle having a charge of 1.6. So charge value is 1.6 into 10 to the power of minus 19 coulomb and mass of 10 to the power of minus 7. Okay, so electric field intensity that is required to support a particle having a mass of 1.6 into 10 to the power of minus 9 coulomb and mass of 10 power minus kg. So what is the amount of electric field intensity? So electric field intensity of a body, okay, you have the electric force acting on the body as well as you have what? Gravitational force acting on the, that is due to gravity, which is equal to mg. Okay, downward force due to gravity. This here mg is also will be acting on the same body. So you have to equate F is equal to mg. Okay, now you have to find what is the electric field intensity. So we know that F is equal to QE. Okay, force experienced by the charge. The electric field is given, F is equal to QE. So just use this, QE is equal to mg. Okay, therefore E will be equal to mg by Q. Okay, so substitute the values. 10 power minus 7 into 9.8. G is nothing but G is acceleration due to gravity is 9.8 meter per second square. Okay, divided by 1.6 into 10 to the power of minus 19. Okay, so which is equal to 6.125 into 10 to the power of 12 Newton per coulomb. So option is A is the answer. So just to support the body, electric force will be equal to the gravity, and we knew that force is equal to Q into E. So you make use of this formula and just equate it, then you can find out electric field intensity of the body. Okay, are you clear with this concept? Okay, thank you students. Kindly like, share and subscribe the channel. The next coming videos will be dealing about potential and potential energy. Okay, we'll be dealing about some MCQs related to potential and potential energy. So kindly go through the videos. I hope that you get benefited. Thank you so much.